This is a question a lot of engineers carry quietly. Should I be moving into ML? Maybe you have watched this space grow for a few years. Maybe you have even started something, a course, a project, and then life got in the way. Or you are a fresher just starting out and everyone is talking about AI and you are trying to figure out where you actually fit in. I get it, and this video is for you. Not a list of 100 things to learn, step-by-step plan built for where things actually are in 2026. Let me give you a quick picture. In 2018-2019, an ML engineer collected data, trained a model, maybe deployed it. One person, full loop. By 2021-2022, the job got more layered. Pipelines, automation, deployment started mattering as much as model accuracy. Now in 2026, there is a new layer again. Large language models are at the center of most new AI products being built. ML engineers aren't just training classifiers. They are building a system that retrieve, reason, and act. And here is what I want you to hear. This doesn't make ML harder to get into. In a lot of ways, it opens more doors. Because the job is less about reinventing the technology and more about knowing how to build reliably with it. If you have a software background, a data background, a strong CS fundamental, you have more of a head start than you would probably think. Step 1. And if you are already working in tech, you are further along here than you think. Python, statistics, linear algebra. If you're an engineer, you likely have Python. If you are in data, you probably have the stats. You are not starting from scratch. You are filling gaps. What is different in 2026, even at the foundation level, is the mindset. ML doesn't live in a notebook anymore. It lives inside a product, which means you need to write modular and testable code. You need Git, APIs, and environment management. The engineer who understands from day one has a fundamentally different trajectory. Before we get into the LLMs, I want to spend a moment here because this is the step people are most tempted to skip. I understand why. The newer stuff feels exciting, but here is something I have seen happen more than once. An engineer jumps straight into building the LLMs, puts together an impressive demo, walks into an interview, and can't explain why their model gives inconsistent results. Can't talk about evaluation, doesn't have the vocabulary to debug what's going wrong. Classical ML isn't a detour. It's what gives your LLM work a backbone. And it's still running enormous parts of production. Fraud detection, credit scoring, demand forecasting, search ranking. This isn't legacy. This is the world. What you need is scikit-learn, model evaluation such as precision, recall, or AUC. And the intuition to look at a problem and know what approach makes sense. 6 to 8 weeks. And this is where ML starts to feel genuinely satisfying. Hold on to that feeling. It matters. This is the part that's genuinely new in 2026. Large language models. The technology behind ChatGPT, Gemini, Claude. They're not just chatbots anymore. They're reasoning engine inside real production systems. As an ML engineer, you are not expected to build them from scratch. You are expected to work with them, fine-tune them, connect them to the real data, make them reliable, and build systems around them that hold up. 2 concepts you need to understand deeply. First, RAG, Retrieval Augmented Generation. LLMs on their own can make things up. They don't know what changed last week. They don't know your company's data. RAG fixes this. You give the model access to the knowledge base, it retrieves the relevant context first, then it answers. More reliable, more useful, more honest. An agent is a system where the model doesn't just respond, it acts. It decides which tool to call, calls it, looks at the result, and decides what to do next. This is where enterprise AI is genuinely moving right now. What do you need at this step? Hugging Face for working with pre-trained models. How to build a RAG pipeline, embeddings, vector databases, retrieval, LangChain or Llama index for orchestration, and PyTorch basics. 8 to 10 weeks. Don't rush it. One solid RAG project at the end of the step puts you ahead of the majority of the candidates applying right now. And actually, one of the projects the students at Interview Kickstart absolutely love building is something called a resume coach. You feed your resume a job description. It tells you, are you good fit? Where are the gaps? What should you highlight? It's built on LLMs and LangChain, exactly the stack we just talked about. Real problem, real output, something you'd actually use. That's the kind of project that makes an interviewer sit up. Step 4 is what separates people who know ML from people who do ML. It's one thing to build a model that works in a notebook. It's another to make it work for real users. Under load, when data changes, when things go wrong at 2 a.m. in the morning. And in 2026, there is a new dimension here. Because LLMs are non-deterministic. The same input can give different outputs. They drift, they hallucinate. Monitoring them requires a completely different toolkit. This has its own name now, LLM Ops. You don't need to become a DevOps engineer. You need enough fluency that when an interviewer asks how you deploy this, you have a real answer, not a hand wave. 4 to 6 weeks alongside your project work. You don't need 10 projects. You need 3 or 4 that show you can think through a real problem and build something that actually works. The shift in 2026, a project that lives entirely in a notebook is hard to evaluate. A project that's deployed, has an endpoint, has some monitoring built in, that tells a complete different story. It tells the team, this person understands the full look, not just the model. Clean GitHub, a README, a stranger can understand. And write about what you built, even a short LinkedIn post. If you can explain it in writing, you can say it in an interview. That's exactly what they're testing. If you want to see what good projects look like, watch the demos made by the learners at the end of this video. ML interviews in 2026 have 3 parts. Fundamentals, still very much there. Bias variance, gradient descent, regularization, cross-validation, when to choose which model and why. If anything, these questions are harder now because everyone claims to know ML. Coding, lit code medium is still the bar. Arrays, hash map, trees, SQL, and increasingly writing Python that's actually clean, not just working. ML system design. This is what's changed. You will be asked to design a Q&A system that doesn't hallucinate. How do you handle cold start in a recommendation engine? How would you monitor an LLM in production? These questions test how you think. Can you reason about trade-off? Can you talk about failure modes? Can you draw a system that actually put in front of users? This is the part that's hardest to prepare for alone. Not because it's inaccessible, but you need to practice thinking out loud, get feedback from people who have actually been in that room. Quick, honest timelines, because I think this matters more than people say. If you are switching from tech role, 6 to 8 months, 90 minutes a day. If you are a fresher, give yourself 10 to 12. If you are coming from data or analytics background, probably 5 to 6 months. A lot of transfers. The timeline isn't the hard part. The direction is. Knowing what to study next, knowing where you are ready, knowing whether your interview answers would hold up. That's where people lose months, not from lack of effort, but from lack of feedback. That's what Interview Kickstart is built for. The ML program is taught by engineers who have worked and interviewed at Google, Meta, Amazon, Microsoft, Apple, you name it. You get a structured curriculum, live mock interviews with real engineers, project reviews, and a community on the same path. Interview Kickstart, it's not the shortcut. They are the structure that makes your effort count. If you want to meet the team, no pressure at all. It's a conversation with someone who will genuinely help you figure out your next move, whether that's IK or not. Subscribe for more, and I'll see you in the next one.